Good evening. This is Kavipriya, Assistant Professor, EC Department. Today I am going to discuss about the topic function generator. So what is a function generator? So function generator is a signal source that has a capability of producing different type of waveforms as its output signal. The most common waveform that are produced by this function generator are sine wave, triangular wave, square wave and sawtooth waveform. The frequencies of these waveforms can be adjusted from hertz to several hundred kilohertz. And next is the working principle of the function generator. So it consists of an oscillator circuits. So function generator utilizes oscillator circuits as their core component. This circuit generates the primary waveforms sine, square, triangular based on the user's selection. Next is the waveform selection. Users can choose different type of waveform through the selection switches or controls. Common waveform includes sine, square, triangle, sawtooth and pulse. Next is the frequency control. Function generator allows the user to adjust the frequency of the generated waveforms. Frequency can be adjusted with the specific ranges based on the type of the applications. And next is the amplitude adjustments. The amplitude of the signal, which is nothing but it is a voltage level, can be controlled to the based on the requirement of the application using this amplitude adjustment. So it ensures that it is compatible with various devices or circuits being tested. And next is the modulation features. Some function generator offer this modulation capabilities such as AM, FM or pulse width modulation, amplitude modulation, frequency modulation or pulse width modulation. This feature enables a generation of more complex waveforms or simulate the specific modulation techniques in the communication systems. And next is output impedance and protection. The function generator usually will be having a defined output impedance to match the typical loads and prevent the damage to the devices that is being connected to the function generator. Output protection mechanism ensures the safety of both the function generator and also the equipment that is being connected to the function generator. And this is the block diagram of the function generator. It consists of a frequency control network, constant current power supply source, integrator, voltage comparator, multivibrator, resistant diode shaping circuits, and we have the two output amplifier 1 and 2. In this instrument, first is the frequency is controlled by varying the magnitude of current that drives the integrator. This instrument provides a different type of waveform in the frequency range of 0.01 Hz to 100 kHz. The frequency control voltage regulates the two current supply sources. Current supply source 1 supplies a constant current to the integrator whose output voltage rises linearly with time. An increase or decrease in current increases or reduces the slope of the output voltage. The voltage comparator multivibrator changes the state at the predefined maximum level based on the output of the integrator. This changes cuts off the current supply from the supply source 1 and switches to the supply source 2. The current supply source 2 supplies a reverse current to the integrator so that output drops linearly with the time. When output attains a predetermined level, the voltage comparator again changes the state and switches on to the constant supply source. The output of integrator is a triangular wave whose frequency depends on the current that is supplied by the constant current supply source. The comparator output provides a square wave of same frequency as output. The resistant diode network changes the slope of the triangular wave as the amplitude changes and produces a sinusoidal wave with less than 1% distortion. And next is applications of a function generator. Function generators can be applied in various domains. First one is a semiconductor domain. It is in semiconductor domain, FG function generator is used for testing the DC power supply. It is also used for testing the delay margin, and it is used for analyzing the audio digital to analog converter, and it is used to test the clock frequency functional ranges of digital circuits. In medical domain, it is used for testing the medical ultrasound devices, pacemakers, implantable medical equipment and other detector circuits. And also it is used in radio frequency domain, and it is used for calculating the band pass filter frequency responses. It is used in EMC radio observations. It is used in operational testing of RFID receiver integrated circuits. It also measures the pulse noise figures. In automotive domain, it is employed for testing and optimization of engine control units. And next is the advantages of a function generator. So it is used for generating the different waveforms, and also the frequency can be varied up to several megahertz frequency. It can be generated. It can be used for generation of waveforms like square, sine, triangular and sawtooth waveform, and the calibration is internal. And drawback is that they are usually not suitable for application that need low distortion or stable frequency signals. So that's all about the construction, block diagram of function generator, working principle, applications and advantages and drawbacks of the function generator. Thank you.